Okay, guys, just a quick recap of what we've mentioned last week from here, guys. Basically, we learned about electric charges, right? Like I mentioned last week, charges are very similar like magnetic field, just that they, instead of a magnetic field, they will exhibit an electric field, guys, right? And we said that the positive charges, the electric field will radiate upwards, just like a north pole. And the negative charges will have electric field radiating inwards, just like a south pole, right? Then I also told you that this in your exam, right? What they like to do is they like to ask you how did the electric field came to be, or define what an electric field is, guys. I mentioned this last week. I'll say this again. The electric field is an imaginary thing. There's no such thing as an electric field. So how did the scientists came to know that there's electric field upwards and inwards is by placing a small positive charge here. And he observed the force exhibited by this positive charge. Obviously, when I put a small positive charge here and this is positive, they will be repelled, right? And then if I have another one here, it will be repelled, another one here, repelled, right? This is how electric field came to be. Same thing for negative charges as well. If I put a small positive charge here, you'll see that it's being attracted, and so on, right? That is why these 2 points are basically explaining what an electric field is. Guys, in your exam, you can write either one of these two is acceptable. I said that electric field is not as is a region in which an electric charge, which is that small positive charge, or this small positive charge here, experiences a force. Or you could say something like direction of an electric field at a point is the direction of the force on the positive charge at that point. Basically, you can restructure it in your own way, right? But you need to know that there is the reason why there is electric field is because of the force experienced by that small positive charge, guys. There is a small positive charge here, and then if see where's the force here, okay, then you'll be pushed upwards. Okay, very important now, guys. Everyone must know this. And obviously, same thing, right? Unlike charges are going to attract, the like charges are going to repel, just like the boys and the boys and the girls and the girls. Unless you're into that, like I mentioned last week, then it's a different story. Then after that, last week we ended class with the video of this gold leaf experiment, right? This gold leaf electroscope. Basically, in the gold leaf, do you guys remember the video? I showed you guys a video, right? Right. You guys remember how the flow of charges work or not? Right. So yes. So from here, like I mentioned last week, guys, there's 2 ways of induction, guys. We could charge up the metal plate in 2 specific ways. Let's look at the first one here. I'll explain it in detail again, guys. Remember that every time something is able to build up charges is because of the flow of the negative charges, guys. In chemistry, you learn this, right? You learn about free moving electrons, right? Free moving electrons basically means to say the negative charges are free to move about. But the positive charges cannot move, guys. The positive charges by right are supposed to stay there, right? So what happens here is, in a normal scenario, this thing, like all objects, will be neutral in nature, right? It will be neutral first. If it is neutral, it means to say the amount of positive charges is equals to the amount of negative charges, right? And because they are equal, there will be obviously no deflection. And when there is no deflection, what happens next is, if today I want to induce this, I want to induce negative charges onto this gold leaf here, what I actually do is I place a very negatively charged rod and I touch it. Wait, pay attention now, don't look around, pay attention here. I take this negative charge and I touch it onto this metal plate. So what happens here is, right, straight away, these excessive amounts of negative charges in the rod will detect that, oh, I have a means of escape right now, right? And if I have a means of escape, what it means to say that the negative charges will be repelled downwards, right? It will be repelled downwards, and then after that, when I remove this rod, this thing here will be left with negative charges, because this rod supplies the excessive amounts of negative charges into this gold leaf here. Okay, this is what we call charging by contact. I actually need to touch the thing to allow the negative charges to flow from the rod to the plate. Okay, this is what we call charge by contact. There is another way known as charging by induction. The main difference here is that you see this rod here, it is hovering above the metal plate. It will not touch the metal plate. Why? Because what happens here is, right, today, as I bring this negative charge rod close to this metal plate here, the original negative charges here, right, detects that, oh, there is a negative charge repelling the negative charges downwards. So initially, before we put the earth wire, the negative charges will be repelled downwards. That's why the top part will be left with positive, right? Guys, the reason why it is positive here is because there is a lack of negative charges. Very important, I need to know this. There is a lack of negative charges. That's why this part here becomes positive. Then after that, what I do is I connect an earth wire here. Guys, I mentioned this last week, guys, but I'll say it again. For earth wires, you can just imagine it as a bridge. It's a bridge for negative charges to flow in and out. In this case here, obviously right now there is a bridge here, right? All the negative charges that will repel down here, they will be escaping through this earth and down to the ground, right? And then after that, guys, after that, I must remove the earth wire first, then only I remove the rod, right? Then this thing here will be positive charge. Why do I say that I must remove the earth wire first? Because imagine this, guys. Imagine if I did it the other way around, which is the wrong way. This is the wrong way. Pay attention. This is the wrong way. Don't do this in your exam, guys. If I remove the rod first before I remove the earth wire, what's happening is as soon as I remove this rod here, right? All the positive charges here will attract the negative charges back from the earth wire to the ground. Right, so then it will neutralize the metal plate again, right? So that's why I must remove the earth wire first. Anyone don't understand what I'm talking about for this part here? I can repeat this. It's very important. It will be asked in your exam. Anyone don't understand this part? This is important. Anyone wants me to repeat this? It's okay, good. At least you're honest. Very good. I will explain it again. Okay, pay attention. Initially, before this thing was here, this thing was neutrally charged, right? So positive equals to negative, positive equals to negative, right? Initially, then hey, pay attention, right? Then after that, I place this negative charge rod very, very close to this plate here. I don't touch it because this is charging by induction only. Okay, so when I place this negative charge very close here, what happens is the original negative charges here will detect that, oh, something is repelling me, right? So it will repel the negative charges downwards initially. Then I connect an earth wire here. When I connect an earth wire here, the negative charges at the bottom here decides that, oh, I have a means of escape already, because right now I have a bridge to escape. So all the negative charges will be repelled down to the earth, right? As they are repelled down to the earth, I remove the earth wire first so that the negative charges cannot come backwards, right? So that the negative charges cannot come backwards, then only I remove the rod, right? Imagine a wrong scenario. Imagine a wrong scenario where I remove the rod first, then only I remove the earth wire. You know what's going to happen? As soon as I remove the rod, these positive charges here will detect that, oh, I'm lacking negative charges. So all the negative charges will come from the earth and back to this plate here, making it once again neutrally charged. Okay, so we always remove the earth wire first so that the electrons cannot come back. Then I will retain my positive charges here already. Do you guys understand what I'm talking about? Yes, sure. Hey, Brad, I tell you, this one will come out in your exam. You must know. In fact, later on, the next question, you will see it already in the next question here. Okay. So anyone online uncertain with what I've mentioned, this is very, very important. You must know this. You must always remember, you remove the earth wire first. I actually write this down on the side. Remove earth wire first so that the charges have no means of escape. Okay, write this down in a second. Must remove the earth wire first. Okay. Okay. Then the final part here. You did. You're fucking listening with your eyes closed again. Okay, then the final part here, right? Charging by friction, guys. This is essentially what I've mentioned already last week, guys. Like I told you, when you rub two objects together, one object will have a tendency to accept negative charges. One object will have a tendency to donate negative charges. So this is also the reason, I think I mentioned this last week, right? This is also the reason why when you're walking in the shopping mall, you feel the electric shock when your friend touches your hand, right? So what happens is, let's say today, this is you, right? And this is your friend here. This is your friend here, right? One of you guys is most likely going to have more build-up of negative charges because you keep walking on the carpet lah, have friction with the air molecules there lah, right? And then anytime there is friction, you'll probably induce charges. One of you guys will probably have more charges. Let's imagine now today, this guy here is positive, negative, positive, negative, positive, negative. And because he lacks one negative charge, he'll be positive here, right? Whereas this guy here is positive, negative, positive, negative, positive, negative. Then he has excessive one more negative charge here. So this guy is negative here, right? One of you guys is most likely more negatively charged. One of you guys is most likely more positively charged. And when you guys touch, right, all things will try to neutralize itself. So what happens is this excessive negative charge is actually transferred, is donated to this guy here, right? That's why you can feel that small little spark in between your hands. This small little spark is basically a super small scale of how thunderstrike happens. Did I mention how thunderstrike happens last week? I did, right? Basically, the clouds are basically having friction with the air molecules here, and they're building up charges here. As soon as they build up a lot of charges here, then thunder strikes down to the relatively more positive guy. What's this? Yeah. Then after that, this is essentially the flow of negative electrons only. Okay. So if you look here, when an insulating material rubs against each other, they may become electrically charged. Okay. Electrons which are negatively charged may be rubbed off one material and onto the other, right? Usually, one will have a higher tendency to donate, one will have a higher tendency to accept negative charges. Materials that gain electrons obviously become negatively charged, and material that loses electrons are left with a positive charge, right? So in order for it to be positive, there must be a lack of the negative charges, guys. Understand what I'm talking about? Okay, good. Everyone, start doing the first three questions here first. I'm going to give you guys like probably 7 minutes to attempt this. Then after that, we'll discuss the answers and I'll show you how a real RGCSE question is going to ask you. Okay, everyone do this right now. Do the 3 questions right now. What? But like, we opening on. Here on spot or here also on spot. I want to choose here. Here, sit in the big hand. Space. 你不要跟别人说是不是？去这边是的。这个还推进去，有好多吗？Yeah, Abigail, you know how to speak Chinese. You do, so you understand everything we say, is it? Who taught you? Your brother also went to a Chinese school, right? You know, our brother, when he first came in, he was grouped with these China students, right? And he never said one time that he understood Chinese. He just sat there and listened to all of us. Wow, we speak Chinese. And then he never said one thing until I think Nishan came and talked about Aaron. He's like, oh, he knows Chinese word. What? I think they haven't talked shit about Aaron. Chen, I feel paper empty. Write down something, preferably with a pencil, because you know, might be wrong. How about space? See, everyone is starting off with question number 5, but skipping 3 and 4. Eugene, what's your answer? Let me see, Alex. So, let me see if you got the concept or not. First, what did I just say? What's the thing that's being transferred? What is the thing that's being transferred? The positive charges. Like I said, because when I say free moving electrons, what did I say? The positive charges are going to move. That's why I call it free moving electrons, is it? Good. It's not going to be here now. It's a row. Oh, very good. That's the right answer. Okay, everyone. Since I see that some of you guys are stuck and don't know absolutely what to write, right? Let's go through the answers together, shall we? Right, if you look at this first part here, what is this? What makes copper a better electrical conductor than polyethylene? Guys, copper is a metal, right? Metals can conduct electricity because they have what? Thank God. But why? Why is copper an electrical conductor? What's the condition for it to become a conductor? It must have what? Good. It must have free moving electrons, ma. Why we cannot transfer electricity with plastic or rubber? Because the electrons are embedded onto the material already. Whereas metals, such as copper, they have free moving electrons, guys, and that is the key word. So you're going to say that copper, okay. I'm going to say that copper is a metal which has free moving electrons. The free moving electrons is the reason why electricity or heat can be conducted easily on metals. Okay. All right. The keyword here is free moving electrons. So then this one here is a bit of a conceptual question now, which I expect like maybe most of you guys not able to answer it, but it's fine because you've never learned this before, right? Hey, listen up, guys. Usually, right, it's easy for us to charge up polyethylene, but not copper. Why? Because polyethylene is considered an insulating material. When I rub them together, right, what's happening is if I conduct negative charges onto the polyethylene, it will be stuck there already, right? The negative charges will be stuck on the polyethylene. Then means to say they can retain their charges. But if I have a copper rod and I keep rubbing it, right, what's happening here is as I rub charges onto this copper rod, it will conduct it straight away because copper is a conductor, right? It means to say copper cannot retain its charges simply because it has better conductivity. Okay, every time I induce charges on it, it will just conduct it away straight away. So if you look at this answer here, copper is actually a conductor. Conductors do not hold charges, guys. They conduct it. This means that they transport it away. Charging up a conductor may transfer charges to it, but it will easily conduct it away, guys. As soon as I charge it up, it will conduct straight away already. Okay. Right? Okay, then the final question here. Before I ask you guys a real IBCSE question. When a hair comb combs through the hair, yes, I do realize that it sounds weird here. When a hair comb, I think there should be another comb, right? Combs through the hair, the comb becomes negatively charged. Why? Imagine today I have this hair comb, a poorly illustrated jagged hair comb here, and I have hair here. As soon as you right, long Rapunzel hair, but very little volume hair. So tell me, as soon as this hair combs through this, right, it says that the comb becomes negatively charged. Why? Why will anything become negatively charged? Newton, why will anything become negatively charged? Is it because the positive charges from the comb are going to the hair? Definitely not. Raquel, why? Next week test. All right, so then tell me why. Why will the comb become negatively charged? You. How can the comb become negatively charged? How? What did I say just now?
Free.
Huh? Yeah, where does the negative charge come from? In order for this thing to become negatively charged, the amount of negative charges must be more than the positive charges, right? Right. So my question is, where did the extra negative charges come from? From the hair, right? So basically what happens is, as this thing combs, as the hair comb combs through the hair, the negative charges from the hair will be donated into the comb, right? The negative charges from the hair will be donated to the comb. And then this comb will become negatively charged, right? Like I've mentioned here. Right now, why is it like everyone don't know how to answer, bro? Negative charges, right? Charges from the hair is donated to the comb, thus making it negative charge.
Why we are donating it?
Because when two materials rub together, one will always have higher tendency to donate, one will always have higher tendency to take on one. So they will like take on the negative charges, accept negative charges. Two materials always like that one. But every material is different, but you don't have to know that. You just need to know that when two materials rub, one has a higher tendency to accept negative charges, one has a higher tendency to donate negative charges. Okay. Please remember my beautiful picture as reference. Hey, shit. What the? Wait, wait. Sorry. Okay, everyone. Good. You see all these questions here? They're going to be your exercise for today. But before you guys do your exercise, let's flip to this page here and go through the question together. Let's do this and go through the question together. Okay, if you look at this question here, this is a Very, very, very standard IGCSE question. Are you must know how to answer this because it is as free as it can be already. Okay, starting off with the first question. Figure 9.1 shows a positively charged rod, a metal block resting on an insulator, and a wire connected to the earth. So there is this earth wire, which is not connected yet to the block, and this positive charge rod, and it's brought very close to the metal block. And then you can see that this part here is an insulator. Guys, let me tell you how to analyze this question. First things first is, if you see this insulator on the metal block, right, this means to say that this metal block will not be able to accept or donate negative charges unless through contact, meaning to say in this current situation here, it is neutrally charged, means to say the positive charges is equal to the negative charges here, right? Then here straight away they ask you on figure 9.1, draw the charge distribution of the metal block. So how do you think I should draw this? I know that this thing here is neutrally charged. So I know for a fact that it is the positive charges must be equal to the negative charges. But if they ask me to draw a charge distribution, how should I draw this, Melvin?
Plus equal to minus.
Then how do I draw? Just like this, plus equals to minus.
So plus minus.
Where plus, where minus? Here plus, then minus, plus, then minus, plus, minus, like this, is it?
I think so.
No, it is not. Let's ask someone online, shall we? Raj, how do you think the charge distribution will be? How do you think the charge distribution should be when? Oh, how about Leo? Leo, what do you think? How do you think I should distribute the charges? How should I position my positive and negative charges?
Maybe put a minus on the surface.
Very good, Leo. You are indeed an excellent answer. That is indeed an excellent answer. You are supposed to draw the negative charges closer to the surface, which makes sense, right? Because these negative charges are going to be attracted by these positive charges. But the amount of negative charges that you draw must be equal to the amount of positive charges that you draw. So this is your first point here. You will get your first 2 marks just by drawing the positive equals to the negative. Okay. Okay. Then the next part here is where it starts to get interesting already. Look at this guy trying to open the door while still maintaining contact. Hey, if you look at this next part here, it says that the earth wire right now is held against the metal block already. Right now, oh look, this earth wire is touching this metal block already. First questions first. What do you think is going to happen when the earth wire touches the metal block? When a positive charge rod is brought very, very close to the metal block?
All positive.
All positive. From where? Let's ask Leha, what do you think is going to happen here if I have an earth wire connected? What does the earth wire do again? It is a what for what? It is a what for what, Rachel? What did I say the earth wire was for? Good. It is a bridge for negative charges to come in and out, right? So if it is a bridge for negative charges to come in and out, right? And I have this earth wire here. Like how do you think the charge distribution is going to look like right now? Are you there?
Yeah, will it be even distribution?
Even distribution? No, it definitely won't be even distribution. How about Joey? What do you think? how do you think the charge distribution is going to look like? Joey, are you there? Okay. Hey guys, listen up. If I have this earth wire connected here, right? I already say it's a bridge for the negative charges to travel in and out, right? And since this is very positively charged, what's going to happen is the negative charges will be attracted or repelled away. It will be attracted upwards, right? So the negative charges are going to be attracted upwards. So this means to say that when you draw the distribution right now, you must draw more negative charges on top and less positive charges at the bottom, indicating that you understand the negative charges are being attracted upwards here already. And then you get your other one. Easy. Oh, sorry, Raj, which part you don't get? Raj, you understand that this earth wire here is acting like a bridge for negative charges to either flow in or flow out, right? Do you understand this part? Okay, so what happens is, right, today, if I bring this positive charge rod very close to this metal block here, what's happening is I'm actually causing the negative charges from the ground to be attracted upwards. And when they get attracted upwards, right, then right now the charge distribution, instead of having positive equals to negative, right now I'll have more negatives than positive because the negative charges are being attracted upwards from the earth wire already due to this thing here. You understand? Yeah. So just remember, guys, this earth wire here is acting like a bridge for electrons to travel in or travel out. Okay, in or out, in or out, in or out. Then this one here is exactly what I said they will ask you in your exam, right? The charge rod and earth wire are removed and the metal block is left charged. Left charge means to say it retains its negative charges, guys. State the order in which the rod and the wire were removed and explain your answer. Which one should I remove again? Rod first or earth wire first? Good, we should remove the earth wire first because why? Yes, so that the negative charges have no means of escape, right? Which is exactly what you want to write here. Wire is definitely removed first. Why? So that the charges are kept in the block, so that no charges can flow back to the ground, or any asshole, any student who wasn't paying attention, right, and write that the positive charges are moving, you will not be accepted. And they specify it in the mark scheme, guys. You specify in the mark scheme, don't write the positive charges are moving. But you can write it anyway, right? Just say that the wires remove first, then it prevents the negative charges from escaping, or it keeps the charges on the block, or anything in your own words that makes sense is definitely acceptable. Okay, write this down, please, in your own words. May June 2020. That's more very Feiren. I can solve it. So you guys practice now on your own words. I'll give you a minute. I need to print something. 你跟家宝宝我们还有谁来着？你飞来？OK。不啊，于是我们有做到吗？这个？我们做过。Wait, let me check. 你看过这个白纸歌吗？
Yeah.
巴西过啦。诶，这个我们不是做了没喂？We did this 啦，bro。喂，家宝进来，聊完了。
都有
我们不是做了这个 I think I even explain this to you, right？
做过啊，哎呀，
还有
做过。我全部有人做啊，还做啊。
分给你吧，他们其他有自己的方式是，这个我们做了啊，顶雷啊，你在发动啊那一天，
我没有来，
你
在家
you
吗
online right you should be doing it also what？对，好，print 下等那个 printer accept 不可以，OK。Okay, guys, and then finally they ask you to name this process here. This is what we call charge by induction. You could say it's charging by induction. You could say that it's in. Oh, you cannot say this. Right, just say this is direct charge by induction because I'm inducing negative charges onto this metal block here, right? That's why it's called charge by induction, guys. Or you could say charging by induction or anything along the lines. But I would have written charge by induction. Okay, charge by induction. Okay, everyone, any questions with anything I've mentioned? Okay, guys, you must know how to write this one. This one here is a very common IG question, this school question. Okay? Make sure you read through everything and make sure it makes sense in your head. But having said that, if you have no questions, start doing the ABC part first. I'll give you guys 7 minutes to do everything, then we'll discuss the answers. Do the ABC part right now. Yes, here. Right now. Everyone start doing this. 係嘅得啊，要下當年，不要那麼膽小啦。Okay, check your answers, my guys, with the first few questions here. Just check your answers straight away. The first one is supposed to be boy. The second one, first boy, second A, 3, C, 4, boy, 5, C, and the last one, donkey. I repeat, boy A, C, boy C, donkey. You get everything correct or not? Okay. Anyone's got any questions with the ABC part or not? I repeat, the answer, boy A, C, boy C, donkey. Anyone's got any questions with the ABC part or not? The balloon one? As these two balloons X and Y are suspended by insulating threads. And again, this is the insulating thread, means to say only through touching will it become another charge. They are each held near a negatively charged balloon. The balloons hang as shown. So this one here, you can obviously see that they are repelling each other, right? Means to say this must be negative, right? Right, and this one here is obviously attracting to each other, so this must be positive. No. Make sense? Any other questions? Any? No more? Okay, good. If you have no questions, right? You see everything here, not a lot only, probably 3 or 4 more questions left. 3 or 4 more questions left before you see this page here. Right, before you see this page here, everything is homework. Means to say your homework will be up until page 18, guys. Your homework is up until page 18. Please go back home and do the homework. That means you, Rockwell, and you, and you. Make sure you do the homework. I'll see you all next week, okay? Make sure. Hey, your school is having carnival next week, so you're not coming. You also not coming. Okay, good luck. Yeah, fair enough. Okay, that will be it for today, guys. If you have any questions, you are always more than welcome to stay back. If not, I'll see you all next week.
Okay, bye.
Bye bye. 你的地了，我知道。